Okay, so let's take a look at this. How do we find the mean?
Add up all the numbers together and divide by how many you have.
Okay, so yeah, the first thing we have to do is we have to define n, and n is how much here? One, two, three, four, five, right? N equals 5. N is the number of items in the list. And in this case, the number of numbers in the list. So the mean is found by adding the numbers up. And then dividing by n, which is 5. So that is 65 divided by 5, otherwise known as 13. Very good. The median. We have to go through a two-step process. Now this number, you probably just look at it and figure out which number sits in the middle by looking at them physically. But how do we find the position of the median? Yep. Okay, you can put them in order and cross off the ends to get into the middle. That works. With a larger set of numbers, that can be a little bit tedious. So the other way, once they're in order, we can find the position of the median by just taking 0.5 or 1/2 times n. So in this case, that would be 0.5 times 5, which is 2.5. Now there's two possibilities. Either this is a decimal, like it is here. When it's a decimal, we round it up. The third number in the list is the median. So the third number there is 11. If it's not a decimal, if it's a whole number with no decimal, that means it's between that one and the next one. Remember? Okay. So the next step, we didn't get to talking about measures of spread at all last time, did we? If I recall, we ended up on the mean and median and mode and that.
Measures of centers.
Centers, yep. Measures of centers. So measures of spread. Next time is measures of spreads. That's what I thought. It's that point in the semester where everything's blurring together for me. So, sorry. So measures of center is what we've covered. So now we're looking at measures of spread. All right. Really? Okay, well, hopefully this next part's a little bit past what they're doing. So measures of spread. There's a couple of them we're going to look at. One is range. And we may have briefly mentioned mid-range last time. The range is just the maximum, the largest number, minus the minimum, the smallest number. So for our data set up here, what is the maximum? 25, and the minimum? 4. So that'd give us a range of 25 minus 4, or 21. Now, I can come up with data sets that have the same range, but are not the same spread. Let me give you an example here. I'm going to give you this data set. What's the range there? 24 minus 8, which is 16. What's the range of this one? 24 minus 8 still, which is 16. Are those two the same amount of spread? Would you say those numbers are equally spread out? No, this one here, they're grouped together kind of in the middle except for the 8 and the 24. Here, they're grouped together on the ends and the 16 sits in the middle by itself. I would not say that those have the same amount of spread or dispersion. So the range is not a great measure of spread. It's a quick one, but not a good one. So we're going to look at another one called the standard deviation. What the standard deviation is measuring is the average distance, the mean distance of each number from the mean, from the center. Now there's a long formula that the book gives, And I'm not going to scare you by putting that formula up on the board. We're just going to go through it as a 6-step process. So we're going to do this first data set up here. The 8, 15, 16, 17, and 24. And we're going to go through the 6 steps. Step 1 is to find the mean. So I'm going to add all those up, and there's 5 of them in there. N equals 5, so I'm going to divide by 5. I add those up, I believe that equals 80. Dividing by 5 gives me a mean of 16. Any questions so far? Step 2 is where it starts to get a little more labor intensive. In step 2, we're going to subtract the mean from each value. So you have 8, 15, 16, 17, and 24. We're going to subtract that mean from each of those. We're going to subtract 16. 8 minus 16 is negative 8. 15 minus 16 is negative 1. 16 minus 16 is 0. There we go. 17 minus 16 is 1. And 24 minus 16, 8. That's step 2. Now at this point, if you wanted to double check, you don't have to do this, but if you wanted to double check, that column should add up to 0. If it doesn't, you've done something wrong. That's not part of this process. That's just a way of checking what you've done so far. Step 3. Is to square each of those numbers now. So negative 8 squared is, now some of you, if you punch that in your calculator, it might say negative 64. It's not. What is it? Positive 64. Remember, when you put it in your calculator, you have to put it in just like this with the parentheses around it. Otherwise, the calculator will square the 8 and then put the negative back on front. But a negative 8 squared is negative 8 times negative 8. And a negative times a negative is a positive. Any number squared is always positive. So negative 1 squared is 1. 0 squared, 0. 1 squared, 1. And finally, 8 squared, 64. Any questions so far? On to step 4. Find the sum. What does it mean to find the sum? We're going to add those up. 64 plus 1 plus 0 plus 1 plus 64 is 130. Step 5. Very important. Divide by n minus 1. For this set of numbers, what was n? 5. So n minus 1 is 4. Good. So we're going to divide by 4, which is 32.5. If you were asked, 32.5 is a number, a quantity called the variance. But if we're looking for the standard deviation, there is one more step. That one more step, step 6, square root. So the square root of 32.5 is 5.7. What do you think? Good stuff? Well, for practice, let's do one more together, and then I'll give you guys one to practice. Let's do that other set. 7, 8, 15, no, 7, 8, 16 was that. Make sure I did that right. 8, 9, 16, 23, 24. That's better. Sorry about that. Scratch that. So the other set was 8, 9, 16, 23, 24. What's step 1? Find the means. We're going to add those all together. There's 5 of them, so we're going to divide by 5. If we add them up, they still add up to 80. So we get a mean of 16. What's step 2? Yeah, we're going to subtract the mean from each. So we have 8, 9, 16, 23, and 24. And we are going to subtract 16 from it. What's 8 minus 16? Negative 8. 9 minus 16. Negative 7. 16 minus 16 is 0. 23 minus 16. 7. And 24 minus 16 is 8. Now at this point, if we wanted to double check, what should those add up to? 0. Do they? Okay, good. What's step 3? Not square root, just square. Squared. So negative 8 squared is 64. Negative 7 squared is 49. 0 squared? 0. 7 squared? 49. And 8 squared? 64. What is step 4? Sum, which is going to add up to what? Something's a little off there. I get 226 when I add them up.
I get 226.
Find it? What's step 5? Yeah, divide by n minus 1. So we're going to divide by what here? 4. Which would be what? 56.5? And then, step 6. Square root 56.5 gives us 7.52. 52. Right, 7.5166.
Yeah.
All the amount of numbers in the list, yeah. So you notice 7.52 is bigger than 5.7. So the standard deviation is telling us that this set is more spread out. So it's it's what I call a precise. Precision is the ability to distinguish between two things that are similar. The standard deviation is a more precise measure of spread. It does a better job of separating out those two data sets. Well, for right now, in your notes, I'm going to give you a data set to try. Will that one work out well? Let me try this one. Bless you. I'm going to change this to 25 and this to 31. Then it should work out better. Okay, I'll let you guys try that in your notes. So what is step 1? Find the mean. And what is the mean here? $138 divided by 6, which is 23. Very good. Step 2. Subtract 23. Subtract the mean from each. So we got 7, 18, 20, 25, 31, 37. And we will subtract 23. 7 minus 23? Negative 16. 18 minus 23. Negative 5. 20 minus 23? Negative 3. 25 minus 23. 2. 31 minus 23. 8. And 27 minus 23. 14. If we added those up, what should they add to? Should add up to 0, and they do. Step 3. Square them. Negative 16 squared is 256. Negative 5 squared. 25. Negative 3 squared. 9, 2 squared. 4, 8 squared. 64 and 14 squared. 196. Very good. Step 4. Add them up, which is what? What's that? 554. Does that look right? Okay. Step 5. Divide by 5. I thought we divided by 4 last time. Yeah. N equals 6, so n minus 1 equals 5. So 110.8. And we square root it. Step 6. 10.4 something? 5.3? 10.53 look good to everybody? Nourishman, do you concur? Perfect. Any questions on the standard deviations? So, why do we care? Good question, huh? Well, there are a lot of things. If we can just do the simple mean and median and standard deviation, there are a lot of things that we can put together from it. For example, there's something called the empirical rule. The empirical rule governs all natural data sets, basically. And we talked about the bell curve as the distribution and how most data in nature follows a bell curve. Well, if it does follow a bell curve, that data then is split up in very predictable percentages if we know the mean and the standard deviation. Of course, the mean is in the center. If we go out one standard deviation on each side of the mean, so if we go out one standard deviation this way, that's one standard deviation below. So I'm subtracting one standard deviation from my mean. We expect 34% of all the items, all the values in our population to fall between the mean and one standard deviation below. Same if we go the other way. One standard deviation above, we expect 34% to be in there. Now I want to put numbers in here in a little bit that'll make this make a little bit more sense. Stick with me for now. If we go a second standard deviation below, so minus 2 standard deviations, between the 1 and the 2 standard deviations away, we expect 13.5% to fall in there. And same on the other side. Plus 2 standard deviations, 13.5%. Going to the left, down another standard deviation, down 3 standard deviations, we expect about 2.35% to be in there, and the same on the other side. And more than 3 standard deviations above or below, it's 0.15% on each side. But what does this mean? Well, let's say that you are taking it, you got a job offer, and you want to evaluate whether what they're offering you is a good job. So you look at all other jobs in that area that are in the similar field that you've been trained for, that you're applying for. So we're looking at similar starting wages in the area. Let's say you find that the mean is $15.60. And the standard deviation is $1.80. Let's say you have been offered $13.80. According to the bell curve, the numbers that we are concerned with are the mean and the standard deviation. Now, the percents that I put in here will never change. Those percents are always the same. The bell curve and the percents never change. What changes are the numbers down here because of the mean and the standard deviation. Let me show you. The mean is $15.60. That goes in the middle, 15.60. The standard deviation is 1.8 or $1.80. So as we move to the left, each step is a standard deviation. So I'm going to subtract $1.80. This is going to be $13.80. This is going to be $12. This is going to be $10.20. I subtracted $1.80 at each step. Any questions as to where those numbers just came from? Okay, now going the other way, we're adding $1.80 at each step. So this is $17.40. This is $19.20, and this is $21. So now let's evaluate this job offer. You were offered $13.80. That's right here. So depending on how you want to look at it, let's say that you're asking, I want to know what percentage of the jobs in this area, in the field that I'm applying for, pay more than that as a starting wage. Well, we would add up these percents. They all add up to 84%. So that's telling you that 84% of the jobs in that field, in that area, in the region that you live in, pay more than what you're being offered. Does that make sense? Another application we could look at. Let's say you're looking to buy a house. You want to buy a 3-bedroom, 2-bathroom house. And you have been told that in the area you are looking, the mean price for a 3-bedroom, and you've done some research, you've looked them up, the mean price is $140,000 with a standard deviation of $24,000. Let's go to our bell curve. Now, for what we're going to do next, we don't need any of the information I just gave you up here. All we need are those percents. What percent goes here? 34%. And the same here. What percent goes here? 13.5. And the same here. What percent goes here? It's 2.35, and the same here, 2.35. And then these are 0.15% out here. What number is going to go here? 140,000. I'm just going to put in 140 to shorten it up. What's going to go here? 116. Where'd that come from? Subtracted the 24 from the 140. Good. So what's going to go here? Right on that blue binder there, you can grab the test. Yep. This will be 92. 116 minus another 24 is 92. You can go the other way. And then this will be 68. Going up, this is going to be 164. This will be 188, and this will be 212. Good. So let's say you found a house that you absolutely love. It is priced $188,000. Your realtor says, you need to put in an offer on this house. It's going to go soon. Well, here's $188,000. That's right here. What that is telling you is, if we add up these percents right here, that adds up to 97.5%. That 97.5% of all 3-bedroom, 2-bath houses in that area are cheaper than the one you're looking at. So even though you absolutely love it and it's perfect, there's a good chance you're going to find one cheaper that you still like. Does that make sense? There's a second thing that this mean and standard deviation allow us to do. They allow us to compare things from different populations. So let's say that you guys are taking my class. You're taking my pre-algebra class right now. Let's say that on the first test, test 1, you scored 88 points out of 100. And on test 2, let's say you scored 81 points out of 100. Does that mean you did worse on test 2? Well, you're probably thinking, yeah, it does. Well, statistically, not necessarily. Let's say that the mean score on test 1 was 78%, 78 points, and the standard deviation was 5. So here you tested 10 points above the mean. Over here, let's say that the mean score of all students who took test 2 is 72 with a standard deviation of 4. So here you're 10 points above the mean. Here you're 9 points above the mean. What does that mean? It still looks like you did worse on test 2, doesn't it? But the standard deviations are different. We can use something called a z-score. A z-score is found by taking a number, subtracting the mean from it, and dividing that difference by the standard deviation. One quirk in statistics is within a data set, the number of standard deviations you are from the mean is consistent, no matter what the mean and standard deviation of that data set is. So let's look at the z-score for test 1. The z-score, what's your score? 88. What's the mean? 78. And the standard deviation is 5. So we're going to subtract. Our score minus the mean, 88 minus 78 is 10. Divided by our standard deviation of 5 gives us 2. Now it's a positive 2. It's important that it's positive. Positive means it's above the mean. The 2 means it's 2 standard deviations above the mean. So that's not too bad. If we went back to our bell curve up there, that'd be saying, hey, better than 97.5% of the students that took it. In your notes, I want you to try to find the z-score for test 2. So we have a score of 81 minus a mean of 72, and we're going to divide by 4. 81 minus 72 is 9. Divided by 4 is 2.25. That test score is 2 1/4, or 2.25 standard deviations above the mean. That's a more impressive score compared to the rest of the group. Let's look at another place where this can be applied. Let's say that you get a job as a manager in a large store, a retail store. You have to get rid of one employee. You've decided you've got it narrowed down to 2 employees that you're going to get rid of. We're going to call it one employee who works in toys, so we're just going to name him Toys. One employee who works in electronics, so guess what his name is? Electronics. I know how creative I am. You've decided that whoever has the least productive week this next week is out the door. So your salesperson that works in toys sells $1,800 worth of toys the next week. Your salesperson from electronics sells $4,200 worth of electronics. Does that mean the toys guy is gone?
No.
Not necessarily. We have to look at everybody else who worked in each department. Let's say that all associates, all salespeople in toys had a mean sales of, pretend that says mean, $2,800, and a standard deviation of $400. And let's say that for electronics, they had a mean sales of $6,500 and a standard deviation of $600. So we're going to find a z-score. The z-score for our associate in toys. How am I going to find that? It's the number minus the mean. So it's 1,800 minus 2,800 over 400. So 1,800 minus 2,800 is a negative 1,000. Divided by 400 is a negative 2.5. So their sales production is 2.5 standard deviations below the mean. That's what the negative means, is it's less than the mean. Take a couple minutes, find the z-score for our person in electronics. So how do we figure it out? 4,200 minus 6,500 over 600. So 4,200 minus 6,500 is a negative 2,300 over 600, which is a negative 3. So who's worse? Electronics guys, out the door. Does that make sense? Sure. I'm seeing some confusion out there. You guys okay? Okay. Now there are other ways that we can measure position like this. The z-score is a measure of position within a data set. Another way we can do that is percentiles. A percentile is another way of comparing a value to all the other values in its same data set. There's 2 things we can do. We can have a list of numbers and be asked to find a certain percentile, or we can be given a list of numbers and ask what percentile is a certain number in. And we're going to try to do both here. First step is always to put the numbers in order from smallest to largest. So I'm going to give you a data set that's already in that order. 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14. We'll go 15 numbers. So right here I have a list for n equals 15. There are 15 numbers in the list. If I ask you to find the 60th percentile, this is why I stressed using position to find the median. Because if you know how to find the median, finding the percentile is the exact same process. Instead of 0.5, we're going to use 0.6 because we're looking for the 60th percentile, which is 0.6. And what are we going to multiply that by? N is 15. So 0.6 times 15 is 9. Now, when we were talking about median, what did we say happened when it was a whole number like that? Yeah, that means it is between the 9th and 10th number in the list. So we're going to label this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, the 9th and 10th numbers are 27 and 28. So between them, we just add them together and divide by 2. It's 27.5. What do you think? Good stuff? If I ask you to find the 35th percentile, talk me through it. .35 times 15, which is going to be what? 5.25. Which tells us what? Well, if it's a decimal, we just round it up to the next spot. The number in the 6th spot is the 35th percentile. So that's the 22. So if it comes out to be a decimal, we just round up. Even though 5.25 technically would round down to 5, we always round up, no matter what. So in your notes, find the 75th percentile. So 0.75 times 15 is 11.25. So it is in the 12th position, which is 38. How many of you had 38? Good deal. Try to find the 50th percentile. What are we going to do? 0.5 times 15, which is 7.5, which rounds up to the 8th spot. 27. Is what we did here look familiar? 0.5 is the same number we used for the median, right? The median is the 50th percentile. So the same thing. So what do these percentiles mean? If you are told, I'm sure many of you took the Wisconsin state tests and stuff like that in high school, or you took some sort of standardized test where you've been told that you were placed in the 82nd percentile or something like that. Or you had a child and they said their weight is in the 63rd percentile. What does that mean? Well, if you took a test and you're in the 82nd percentile, what that means is 82% of other people that took the test scored lower than you. If your child is in the 61st percentile for weight, that means 61% of all other children their age are smaller than them. So if you're in the 50th percentile, that means you are right dead in the middle of the pack. You're average. Any questions? Okay, that is a great point to stop and take our break. When we come back from break, we're going to go in the other direction. And then we'll review for our last unit test, which comes up on Thursday. And then next week, Tuesday, is our final test, our cumulative final. Remember, that one is more to evaluate the course than you. The only way you'll be penalized on that one is if you don't take it. Okay, let's take our break. It is 4:19, 4:20 right now. Let's come back at 4:30.